Hey, welcome back, everyone. Another Let's Ship It with AWS Machine Learning, but this time we're live from Remars.
This is so crazy being right next to you.
It's so crazy.
This is awesome.
So episode 4 is today. Actually, you know what? Who am I? Who are you? Hey, everyone. My name is Aaron Hunter. I'm a senior technical trainer with AWS Training Certification, and with me we have
Fred Gratian, another senior technical trainer with AWS.
All right. So, Fred, we're going to talk about personalization.
That's
and
right.
Recommendations.
Yep.
Cool.
That's right, Aaron.
Let's go ahead and pull up our very first slide here. So for those who are here, we have, actually we're not doing slides, we have our AWS Training Certification on Twitch page. So if you are brand new, you can go to words. Oh my gosh, words. aws.amazon.com/training/Twitch to find out more about this episode, other episodes and shows that we currently have. As we can see, there's AWS Cloud Quest, Cloud Practitioner. They launched yesterday. That's
pretty cool.
Congratulations to them. Round of applause.
Awesome.
Round of applause.
Right.
And then if you scroll down, you'll see more about the on-demand shows, any kind of sessions and series that we might have had. And we can see here, Let's Ship It with AWS Machine Learning Edition. If you click on that, Fred already has the tab preloaded, but we can see that we have episode 1, episode 2. If we scroll down on that page, we'll have episode 1, episode 2 you can watch on demand, episode 3 you can watch on demand, and we have episode 4, which is our current episode.
That's right.
Live.
That's why we're here.
Live from Remars in Vegas.
This is so cool.
You can scroll all the way down. Episode 5, 6, 7, 8, and our very last episode is episode 8 on Thursday, July 21st at 4 p.m. Pacific. So 4 p.m. to 5:30 p.m. Pacific, and you can learn more, ask questions, and so forth. So that's where you can go. That's where you can learn more about our current series and the rest of the episodes.
Yeah, it's pretty exciting. After this, we'll be halfway done. It's been really going really quick. So let's jump into this. Hopefully, I'll be navigating things a little bit differently here today, but let's go ahead and do this. There we go. So as Aaron said, this is the Let's Ship It series with the AWS ML edition. And we are on episode 4. So we kind of went through some of the things here, but this is what you can look forward to in the next couple of weeks. We're going to be doing some really interesting things in the visual world next week. So we'll be doing all kinds of fun stuff with convolutional neural networks.
And visual next week.
Exactly. Why don't we just ask the audience here real quickly, how many of the episodes have you watched so far? Is this your first one? Maybe also let us know where you're from. We're out here in Vegas, but where's everybody else from?
I'm from Frisco, Texas. It's a little bit hotter than Vegas right now. Typically peaking around 102.
Ooh,
yeah.
It's a little hot out here too, but
it's pretty hot here.
Back in Wisconsin, I have no idea what the weather is like today. But
Wisconsin's a little bit further north, so it'll be cooler.
Yeah, much cooler.
But let us know in the chat. We do also have chat moderators, so ask questions along throughout the show, and they can help you. And also, we can get those questions back up, and we'll read some of them out loud. So we're listening. We are listening to you. All right, everyone.
Absolutely. All right, cool. So we got some responses back there?
We do have some responses. I see 2 and 3. So some people are saying this. They've watched 2 episodes, 3 episodes, which means they're here for their 4th episode.
That's pretty cool.
Welcome. Thank you for coming back.
Yeah. We just have the Medellin, Colombia people back again this week.
I don't see yet. No, not yet.
They're going to check in.
I see Doug Kelly, one of our chat moderators, and Vivek, another chat moderator.
All right.
Liam's actually over here. Hey, Liam. How's it going?
Hey.
No one else can see Liam.
All right, so real quickly, just to warm up the brains here, we're going to just do a real quick one more poll here, just kind of going back to some of the episodes we've done in the past. We've done the ML workflow that we talked about in week number 2. So just give me your answers here, and just let me know when we've got a few answers coming in here.
We do. One person saying build so far, so we'll see.
Okay.
In which phase of the machine learning workflow would we iteratively adjust model hyperparameters?
I'm glad you read that.
Yeah. Deploy and manage, train and tune, build, or data preparation.
Yeah.
Okay, I'm seeing some more responses. Most people are saying build. Let's see.
Okay, interesting. So, I almost gave away the answer in the question because we call it hyperparameter tuning.
Yes, we do.
So it would be under train and tune.
Yeah, train and tune. All right.
Very good. Okay.
Oh, there's a 2. The 2 came in a little late.
Okay.
Oh, okay.
All right.
Congratulations. You got it.
Excellent. So what are we going to go through today? We're going to talk about how we can use machine learning to create a more personalized experience for your customers, describe some common approach to building these recommender systems, go through the ways that startups and some of the challenges that startups deal with, and not just startups, but a lot of companies when you're starting up with personalization in general. And we'll come back and kind of explain how Sagemaker, we're going to talk a little bit about a service that can help you out to do that as well. And then finally, we'll train, evaluate, and deploy in a demo. And I am going to try and make sure I know I'm going to leave time. I'm going to leave time this time, and we're going to
do
make
some
sure
real stuff. All right, let's do it.
Yeah, pretty exciting for that. Okay. So, why startups should use personalization, right? So there's multiple studies that say it's going to, help customers, with their behavior. And basically what you're trying to keep retention up, attract new customers, and, have them either buy or just have a better experience when they're using your website, all right? So I like the last there, the enhancing customers' lives, right? Because if you're giving them what they're looking for when they come to your site, they're going to have a better experience overall, and that's what we're looking for.
Yeah. We always want our customers to have a really good experience, and when you personalize some products or recommendations for them, I know they get me quite a bit.
Yeah.
So whenever I have something that's personalized to me, I'm like, oh, I kind of want that because it's kind of reading my mind.
Yeah, absolutely. It can definitely be a differentiator for your business, right? So, a lot of different things. And we have different startup challenges. We've talked about some of the same challenges throughout the series here, not having enough data, right? And you think about it, with personalization, you're going to start off and you have a bunch of products. And you have, maybe you have some people rating things. So you've probably watched 1,000 movies, right? Probably in the last couple months, right?
1,000 movies in the past couple months?
Probably, right?
I mean, maybe, yeah.
Okay.
In my sleep.
And how many of them did you rate?
Not very often.
Right, exactly. So that's one of the challenges, right? So we have this issue of that there isn't enough to go off of. So how would I come up with an idea of what I might, rate a product as, et cetera? And what happens when I started with a brand new product? That's another challenge you're going to go through. So we call it the cold start problem.
If it's a brand new product, the cold start. So yeah, that kind of makes sense.
Yeah. So how
do you warm that up? I guess.
Well, let's talk about that.
Okay.
So when we get to some of the different types of models that we work with, we'll kind of get into that a little bit. So again, let's real quick another poll, because we like our polls.
I like polls. If you like polls, type polls in the chat. We're going to poll for polls.
More polls, more polls. Yeah, so real quick here, which of the following personalization use cases are important to your startup? We don't really have an option to do individual multi-choice answers on this interface here, so we'll just kind of
that's because we're streaming to a lot more than just Twitch this time.
We are.
We're on LinkedIn Live.
I know, pretty exciting.
I think we're on YouTube. Yeah, we're everywhere.
We're on YouTube. Yeah. That's exciting. That's pretty exciting. All right. So, what are we getting for answers over there?
So let's see here. Which of the following personalization use cases are important to your startup? That's the question. We have some response options here. So type 1, 2, 3, 4, or 5 if you think 5 is the right answer. Type 5 in the chat. But attract new, highly qualified customers who are more likely to convert. Okay. Increase the average order value for all the customers. Re-attract disengaged customers, so those who might have left, who aren't shopping as much, who aren't buying as much. We'll see. Personalize the user experience.
Yeah.
We were talking about that just now. Yeah. Making me spend more money, or all of the above.
I just think about every time we do go to watch movies or go to rent something or anything else, it's a lot better if you have those recommendations out there ahead of time, and if they actually make sense and they reflect what you're looking for.
I'm seeing a few 4s come in, so we're thinking personalizing the user experience.
Nice.
I think maybe all of the above.
All of the above, probably the likely answer that people will do it. Not that any one of those isn't going to provide value, but more than likely everybody will experience something like that.
Of course, we're also asking, more important to startups here, so maybe attracting new, highly qualified customers.
Yeah, that's a good point. That's a good point. And maybe you have to personalize your user experience to get new customers. So
and the actual answer is probably going to be personalized to their situation.
Exactly. I see what you did there.
Yeah.
Yeah, I like that. All right, so what are the common approaches to building these recommendation systems? So we have two common techniques that are used out there. One's content-based filtering, right? We're kind of using the items in the content, hence the name, the content-based filtering to determine, so I might look at, text, I might look at movies, I might go through and take all the audio out of a movie and translate it over to text. And then go through those and look at the similarities, the content of those.
Are you translating it or transcribing it?
Transcribing, very good.
Okay. You could probably also translate.
I could translate it.
Yeah,
thank you for that. and maybe I'm going to do both, right?
Yeah, you could do both, for sure.
Yeah, so, and then from that, I'm going to find content in there that's similar. If it's a love story, it's going to be probably romance or something like that. So, based on that content, so if I'm reading a particular article or watching a certain movie or listening to a particular song, from the knowledge of what the content is, then I'll come up with recommendation systems. From a machine learning perspective, we might use models like, the unsupervised models where we're looking at, like k-nearest neighbor and things like that. We're trying to find the articles that are close to me, are related to me, right?
It sounds like you're talking a lot about Sagemaker. We talked about that last week.
Why don't we use Sagemaker later on in the series here, and do some of this stuff.
Because we know our viewers and learners love Sagemaker, but we're going to show Sagemaker and Personalize and some of the differences. Yeah,
we'll talk about that. So, and then the other is the collaborative filtering. So that's gets a little bit more tricky. It goes back to the question I asked you: how many movies have you watched and actually rated? Right. And so we look at the fact that not only all the products, whether it is products you're going to be buying, songs you're going to be listening to, whatever it happens to be, we're looking and trying to say, who are some of the people in our neighborhoods? Who are the people that are similar to us? And from that, drive the use case, to drive that. So now I look at the fact that I have someone similar to me, and they rated a particular movie or something like that in a certain way. And it gets complicated, though, because, again, we don't necessarily have all of that data. Not everybody rates movies, right? So how do we come up with a recommendation? So
I wonder, I'm thinking out loud here, I wonder if there's a way to have a recommendation for music based on movies that I've watched.
Ooh. I bet you we can, because you know what? That's just a feature, right? So
it's always a feature away.
Yeah, when we talk about collaborative filtering, that's really one of the things, is that we do have these extra features, the auxiliary features, these related features, a bunch of different phrases that I've had and read in this area, but that kind of help us to go and say, well, they haven't rated this movie, but they do like country music.
Okay.
Yeah. So therefore, they might like Country Strong or a movie like that, or something like that.
And they like other music, so viewers who have watched this movie also have listened to this music. Okay.
Right. Exactly. So it could be any of that kind of data that we can gather, that we can build these relationships with. But again, it gets tricky because there is, if you think about it, mathematically, we can look at here. Let's look at one of the models that we'll use for this type of thing. One of those is called factorization.
Okay.
So, factorization machines, again, it's a supervised model. Remember that, everybody, from the first couple of series, we talked about the difference between supervised and
unsupervised reinforcement,
Yeah, so that means that somebody had to label the data. Well, it makes sense. So, and here we're looking at something like movie ratings.
Okay.
Right, and notice that the middle user only did one movie
on the user item matrix.
In the user items matrix, exactly. So I'm going to have many movies. This is a pretty simplistic view here, but I'm going to have many movies, right?
Yeah.
But let's keep it simple here. If you look at that, there's different techniques that we can use to determine what the first user might have rated as since they didn't rate the movie number 3.
Yeah.
There's a lot of different techniques to go into that, but that we're trying to fill in those matrices. And we have, notice how on that when we we're going to use some matrix math basically to combine these two things. I'm going to have a vector of users, a vector of movies or products, etc. And from those, I'm trying to combine. And then those real value pieces is like we were talking about a second ago. It could be that there is, country music in there. It could be that it's a romance, and we maybe had to do something and use like the content filtering to figure out that there was romance in that thing, and then to make an attribute of this. We want to do some feature engineering.
So country music with romance, less about the dog leaving, more about the dog coming back.
Exactly. Okay. I like that. That's good. And you get your truck back. Yeah. So there's you end up doing combining a lot of different techniques, right?
Yeah.
So, you might choose to set a baseline that says, you know what, for anything that's blank, I'm just going to use the average. So let me look at the average rankings of all of the movies that I did.
Okay.
And then I might plug that into those empty spots.
Could you bin blank as like a 0 instead?
Right. And the problem with the zeros is that if I'm rating something from 1 to 5, a 0 looks like almost like a negative number to the
data
matrix.
Or something. Yeah.
So you don't necessarily like to have those zeros, but the idea here is that we have this data is sparse.
Okay.
Sparse in nature, but yet if you think about it, if I have 1 million users, 1 million products, and I multiply those two things, and I put together into the user item matrix, that's going to be one really big matrix with a bunch of things that were blank at the time that that there were no values for.
Yeah.
So that's where the thing comes into. Now the good thing is that factorization machines are built for this.
Okay, so we don't have to worry about the math and memorizing all the math and doing the numbers and having meme images fly past us.
Yep. Yeah. Okay. Right. And it's really interesting when you get into some of this and look at it. It's pretty elegant, and it works very effectively. So let's go and
what's after this? I think we have another poll, don't we?
Oh, do we? Let's go check it out.
So we talked a lot about factorization machines and music, movies, and how they might pair together based on ratings.
Right. So we talked about content-based filtering there, and
collaborative-based filtering.
Right. So which of these is not content-based filtering? And you can probably figure out the answer by which one of these belongs to the other. Okay,
well, let's see what the entire group says. So all the learners, all the viewers, go ahead and type your answers in the chat. We are watching, okay? So 1, 2, 3, or 4. But which is not true about data used for training content-based filtering? Represent users and items as vectors of attributes or features. Similarity in items are based on their content. Mm-hmm. That one looks promising, but I'm not going to give anything away here. We'll see. Data can be augmented with arbitrary auxiliary features. Say that 10 times fast.
Mm-hmm. That's why you're saying it.
Data that is extracted from images or text descriptions. So I can see here we have a few different options, a few different people typing in. One person said 1. I see some other text and response options coming in. But let's go ahead and see. We'll give everyone a few more minutes.
Okay, yeah, let's go and see.
We'll give them a few more minutes.
Yeah,
okay.
and I think one of the, some of those maybe I didn't actually say the phrase when I was talking about content-based filtering, so that's on me because I didn't give them the right answers. But one of those is very specific to the collaborative. All right, that's what I'll just say.
It is. And I see some 1s. I see a lot of 1s coming in.
Okay.
I see this lonely 3 out there. Data can be augmented with arbitrary auxiliary features.
Yeah, I kind of like that one so far. I think that's a, and I get that one would make sense too, because we are still putting in. I even mentioned vectors and matrices, so I could see
that. Is that one correct then?
Not really. I mean, well, it's true that's true, but in that scenario, we're not really doing the user to to the product crossover like we are with collaborative. So this one actually belongs to the collaborative. So
maybe able to explain maybe why. And that way, hopefully our learners can.
Yeah, we could. It might be easier to go back to look at this graphic again. That's where those auxiliary items that we talked about. The ones that just describe your product. So when we go to the demo, you'll see we don't have ratings. We're actually going to use the quantity ordered.
Got it.
As the key to our collaborative our matrix, and that's what we're going to actually be using for our targeting.
Perfect.
Right. So it doesn't really matter.
No.
and that's the nice thing about the factorizations and the collaborative filtering is that it's not domain specific.
So we can augment the data based on how we need to.
And it'll just figure out, basically on the different features and what the different, those arbitrary values that we tune. And if you kind of dig into it, it's the tuning of those real values over time that makes the predictions get better.
Because as we continue to have more data, we get better and better and better, have stronger predictions, and then maybe even start to evaluate some personalization.
That's right. Yeah, and we're going to come up to evaluations here in a second, aren't you? Aren't you good? All right. Yeah, so I mean that's important to understand that. So that's where those auxiliary values and auxiliary features come in, is to again, that could be the type of movie, that could be the description of the product.
Yeah.
Right, because remember that when we talked earlier. Well, when we get into the thing. Well, I'll ask it to you right now. I'll ask you right now.
Sure.
Is if everybody remembers when we talked about what our features are algorithms like math, right?
Yes.
And we talked about things like state codes.
Yes.
And we said we don't like to
Wisconsin.
We do Wisconsin, WI, and our models don't like having to deal with state codes, right?
You can't do state codes like 2 times WI.
Right.
We're in Nevada now, so it's nev.
Yeah, I guess so. And remember the technique we used to turn those state codes into numbers.
Yes.
Right. We used one-hot encoding. Right.
We can do 1, 2, 3, 4, all the way up to 50 if we need to.
Right. So for each of those states, we created a table.
Yes.
And there was a 1 if it was the right state, then 0 for all the others. Right. So that's another one of those sparse matrices. So when we go into the demo here in a little bit, we're going to see we're stacking matrices on top of each other to come up with our final matrix for training our models. So it's really interesting stuff.
So the question's back up again, which is not true. Data can be augmented with arbitrary auxiliary features.
Right, and we just don't do that in content-based filtering.
Yeah.
That's the trick. So, all right, cool.
So now we talked about a whole lot of stuff, and now we can evaluate personalization solutions using some different techniques.
Yeah. So, like any model, you're going to set some metric that you're trying to either minimize or maximize, right? And same with the factorization machines and these types of models. So there's a couple of different types that we can go through. So, like it says here, it's like you pick one of those to optimize.
Okay.
Just like any other model. But then there are other metrics that are going to tie to your business. How many people clicked on those additional products that we recommended?
Yes, right here where it says best practice to optimize against a single metric closest to the business outcome.
Right.
Okay, so one metric aligned to what they want to accomplish.
Exactly, exactly. And then you're going to have your different metrics that, you might have one that says the click rate, and then somebody else might have another one that says, well, that's awesome. How much revenue did I generate? That could be a different business metric, right?
Are they returning customers, new customers?
That's, absolutely, right? So, and then, so a couple of different ways to test the accuracy of our things. So there's the map K. So that's the average predictions. So we're kind of looking to see how relevant were our predictions to what we were recommending. And then the MAR-K there is the...
Not to be confused with REMARS.
Not even close to being REMARS. Although it's pretty cool that came up here in Vegas. But we're kind of looking to see like how well did it recall the user ratings and reuse those ratings correctly.
Yes.
Right. So we're kind of going through that process. And then once we have them, when I get back some recommendations, I might really think that this is definitely a hit. Aaron's going to love this one. Not so sure about this one, etc. So we might have some ranking metrics as well. So we might say anything that's not at least rated what he would think is rated a 3, don't even bother showing, right? Type of
Based
thing.
on like the movies or the songs.
Right. Exactly.
Okay.
And then we have standard evaluation techniques. This is one, remember, we're going to go and we're going to deploy that thing into an endpoint, right? So we can get predictions from within our applications. So, standard A/B testing where I have, model trained one particular way, a model trained another way.
So one's working, and maybe you make some some tuning changes or adjustments.
Right, exactly.
Okay.
Yeah,
Okay.
so I could have run one with one particular data set.
Okay.
I could run one that ran for more times through the data, like epics, through the
And with
the
A/B
data.
testing, can I send it to like a specific endpoint if I wanted to?
Yeah, so
Okay.
one of the things that we can do with SageMaker hosted endpoints,
Yeah.
right, is that we can then predict, or we can say, go to send 10% of the traffic to this one, 10% or 90% to the other one, et cetera.
Okay.
And then over time, tune that out. And then kind of the multi-arm bandits, that's a longer period of time, and you might have multiple multi-endpoints, and you might have multiple infrastructure set up. And then over time, as your business metrics are telling you which of those is the better one, you start weeding them off until you're down to the last
more
couple.
And more data.
Yeah.
Cool.
So
awesome.
it's kind of based on armed bandits. Here we are in the Vegas with the one-armed bandits downstairs.
Wild
but that's
West.
kind of where they came from, right? Is the certain cold machines, you want to stay away from them.
Exactly.
Right?
So with A/B testing, you mentioned 10%, 90%. Can we do like canary deployments also?
Yes,
Okay.
absolutely. Yeah, right. And there's multiple different ways we can do that when we get into some of the different ML ops practices. And I don't know if we're going to talk about those later in one of our series here, but yeah, absolutely. So
we talked about Personalize and SageMaker and how they kind of compare.
Yeah.
Because everyone loves SageMaker. We have 3 episodes. You can watch them on demand. Learn more about this series, SageMaker in episode 2 and 3. But Personalize versus SageMaker, it sounds like it's going to be a battle.
Could be. And they're two different techniques, right? We talked about this, especially for startups. It might be that you want to start with the personalized service.
Yeah.
And then, so here you're still feeding it data. You're feeding it your data.
Okay.
Right? So you're still having to go and collect your user events,
clicks
interactions.
or the views.
Exactly.
Yeah, okay.
Any kind of metadata about the data, it's like maybe it's the ways you want to classify an article.
Yep.
Saying it's scientific, it's space, it's machine learning.
Okay.
Yep. See where I'm going down?
What is it? Machine learning. What's the A?
You're gonna quiz me here.
I'm gonna put you on the spot. I'm gonna give you an out. It's right there.
There you go. Automation. Thank you. Right.
Automation. So there's machine learning, automation, robotics, and space.
Space. Yes.
So you can kind of bin it and use these different types of
you
categories.
You got it. Yeah. It's been a long week. Thanks for that. Yeah.
It has.
It's funny that you.
No, we have a cheat. It's right there.
We can see that. So nobody else can see that.
Nobody else can see it.
But then my other data, like the fact that why are we all asked to give up our say where we're at, right? Because where I bought that product also could have something, or where other people have. So if you're near that
even
thing,
the location.
Sure. So if I'm near a location, then that might be why I'm going to recommend it. I'm not going to recommend a restaurant in Wisconsin when I'm in Las Vegas, right?
That kind of makes sense.
So
localization there too.
Yeah, exactly.
And user metadata.
Yep. Yeah. So again, look, whether it's profile information, your metadata, like where you're located, what device you're using, that could also determine what form factor I'm going to send this thing
Which
to.
app store you want to go to.
Exactly.
Yeah. Okay.
Exactly. So
it's not a battle. They're kind of going hand in hand.
So there are what happens is that you may find that your particular case, our model doesn't quite meet your particular case, and you want to do further customization, introduce some other data streams or whatever it happens to be. So to do that, we're going to have to use a tool where we can do that, which would be SageMaker. All right.
So is there anything that we can, never mind. I was going to ask about a demo.
Well, we can do a demo.
Have a demo.
Yes, we do have a demo today. So, and just kind of talk through what we're going to go through the demo. So, don't go through the same spiel through it. Well, I will go through the same spiel when I go through the through the demo, actually. But just at a high level, we have our data engineers working with our data scientists.
Collecting all the data, putting them into like an Amazon S3 bucket, for example.
Right, exactly. So we're going to get all this data, this clickstream, these order data, et cetera.
The views, the opens.
And how much they bought, the descriptions of the products, all that kind of stuff. So get all that stuff into into a local data store that we can use. We're going to convert the data from CSV, so we're going to read in the CSV information.
Okay.
We're going to convert that to
value.
Yeah, exactly, and then to convert that to the protobuf. So why do we do the converting to protobuf? If you remember, we talked about that, I think in episode 2,
Yeah.
where we said that that's going to help us basically stream that data in.
Got
right?
it.
It's going to help us kind of speed up that process versus reading the whole data set into memory. Because sometimes we're dealing with hundreds and thousands of millions of products and hundreds and thousands of millions of users. So you can see how that data could get pretty.
A lot of lines in that CSV.
You got it, exactly. So we're going to go through and go through that process for that. Once we've got the data in,
Yeah.
we're going to do some pre-processing of that data because there's certain things we're going to want to do because we're going to have some character data that we want to convert over using one-hot encoding,
Yep.
et cetera, right? So we're going to go through all of that.
And right here it says use feature store, so that everything's just a feature away.
Yep. Using feature store would be an option. We're not going to use it in this particular use case, but
Okay.
but you could use that and you'd have maybe potentially a separate data team that's populating that feature store. So when it comes to training, you can pull it from the feature store.
So you have one data team and another data team using the same data, but in different ways.
Right, exactly.
Perfect, okay.
Yeah, so I can train. And remember we talked about maybe I'm going to parallelly train multiple models with the same data.
Or
right?
A/B testing.
Exactly.
Perfect. Okay.
So we're going to go through
That
the
sounds so
process.
cool.
It is cool. It is cool. It is really cool.
I can see the excitement in your eyes.
It is.
You
It's
lit
hard-
up a little bit.
It's hard not to get, especially here this week. It's hard not to have a really soft spot for this whole process. But going to go through with train. So you can see how coming out of the training here, we go to the model. We're going to register that model in all of its artifacts so we can track its lineage over time.
Okay.
So we can say, man, that one model was working great. How did we create that?
Yeah.
Go back.
How do we do that? Let's
we can
go.
go back all the way back to the training job that was used to train it. Find some different things. Find out where is it stored, so we can say, okay, I want to use that model for my solution, right? So we want to register that model in et cetera.
Because your model's the best model.
In always, right? Well, not always. And then finally, we're going to host that endpoint so we can get some predictions.
So now we have a SageMaker hosted endpoint for these predictions, and then we can point to different endpoints based on some model that we trained that we want to get.
That's
whole
right.
Lot, whole
That's
lot.
right. Okay, so let's see here. So I want to do
Now
one
we're going
thing.
to jump directly into our demo.
I'm going to take one slight thing here since we're kind of navigating here around from. So this is, if you want to learn more about how factorizations work and actually see some of the math behind it all.
Yeah.
You kind of see those two, the VI through VJ. Those are the two different types of those auxiliary features, and the kind of interrelationships of those is kind of what we're trying to look at here. And so we talked about, so you can go and check out exactly how all of this works. You can also see like the different hyperparameters that are used for tuning these things. So in our case, we're going to do a regressor because we're going to actually come up with some numbers.
Regression tasks.
Yeah, because we're coming up with a number of quantities that people would buy. That's our prediction. So we're doing a regressor. So you'll see that when we get there.
Perfect.
And we have, when it comes to the inputs that these factorizations use, so when we look at the inputs and outputs, and this is where we talk about the fact that these like to use the protobuf as an input data set and how we're going to create these different matrices for factorization. All right, so without further ado.
But I don't have to memorize the math.
You do not have to memorize the math.
If you go back to that tab, if you pull up the math and then the symbols and stuff.
Yes,
right? So
it helps.
it helps to know it.
It's one of those things. It's like, we talked about this before. I mean, you can be a citizen data scientist that doesn't want to use and get into all this. If I can give you the data, can you give me the results back? And if I choose the right algorithm and I follow some rules and prepare my data correctly, then you don't have to know the math.
So it helps to understand the math. It helps to maybe know how it works if you want to dig deeper into it, but you don't have to know the math because Amazon SageMaker and even Personalized can help take a lot of that heavy lifting away from you.
That's right.
So that's why that's the power of our services.
Yeah, and there are many examples out there of exactly this use case, right? So this is one of our built-in algorithms, the factorization machine.
Yes.
So we talked about that a couple episodes ago. So we're going to show how we're going to pull that one in. All right, so let's do that. So here we can see we have a recommendation engine for e-commerce sales. We're going to give some shout out here for the UCI machine learning repositories where we're pulling our data in.
Thank you for that data.
Absolutely. And so looking at kind of the data, we have like invoice numbers, stock codes, description of the product. You can't do math. X times the description.
No.
Yeah, that's not really getting much, right?
Description.
Quality, the dates, the customer ID, et cetera. So that's what we're going to go through here. So we need to prepare that data for our model, because this is supervised learning algorithm, right? So we have a couple things. We have to say where the label is that we're trying to use to predict, et cetera. So move that data
kind of
around.
Wrangling the data?
100%. We're going to wrangle that data.
As we go back, we talked about, what was it? We collect our data, then we wrangle the data, then we featureize the data. So right here, we've already collected it, but now we're going to wrangle it.
We're going to wrangle it.
Let's wrangle it.
And here you can see where it says the sparsity of the data is what makes the factorization machines a good algorithm to choose. Because it is this data where we don't have a lot of, not all the features have values. So here we're going to pull in all of the Sagemaker libraries here, and some standard. This is Python-y stuff, right? So we're bringing in all the Python-y stuff.
So
that is a word.
We're doing Python-y stuff here. We're importing some stuff from some stuff.
And you can see some of the different things here we're using, for the sparse matrix stuff here, right? So that those will come in. Our good old friend, our one-hot encoder, some vectorizers we're going to see when we hit that section. This is setting up, remember Boto 3 is our way to interface with a lot of other things like, S3 and things like that. Well, so we're going to use Boto 3 here to interface with our library. Let's go ahead and, I'm just going to add on this to say live. Okay?
Live.
Yeah,
live.
Right? So we'll go ahead.
Episode 4.
We'll just the training job. Someone will be able to recognize that training job. Here's our data. We're going to read in it. So this is our online data we brought from that UCI data set. Kind of looking at what's in the top 10. So you can kind of see we've got some different titles here, different products.
A lantern, okay.
Unit price, the quantity ordered, and things like that, right? So we're looking for any nulls, any empty values here. So we're going to, and we're going to go through and, we're going to say, we got a fair amount of data. So let's go ahead and just drop some of those, any of the null rows. Just kind of get, if they have a null customer ID, et cetera, we'll just drop those out.
Okay.
So we still have 406,000. Sorry.
What is that? 406,829?
That is correct. With 8 columns.
8 columns. And then now we're going to start plotting it out.
Yeah, so we can start looking at things. I'm not going to walk too much into this, but some of the reason there's negatives is because that's how they handle returns. Okay, so that's why we see some negative values. But, again, we talked about this in the second episode about how important it is to look at your data and make sure does it make sense, right? Kind of makes sense here that we're pretty low. Most people don't buy thousands of something. They buy ones and twos and tens and things like that of things. Describing our database data, we can see we do have some pretty interesting maxes. Look at that one there is, so someone did 80,000 of something, so that,
almost 81,000 of something.
That's pretty crazy.
That's a lot of something.
Yeah,
and someone else did negative almost 81,000. The min is negative.
Oh, the min is negative. Yeah, that's the returns.
Okay.
So that's the person that bought all that and then returned all that.
They returned everything.
Yes.
They didn't even keep one.
That's a
bummer. They just didn't like it.
Yeah, it's not, well, because they didn't have room for it.
Oh, okay. Got it.
All right.
Like a suitcase.
Exactly. So we have, our stock code descriptions, et cetera. Here we're kind of go through this stuff. We're going to do a little bit here to move some things here. So we're going to group everything by the quantities that they sold. So we did a quick group by there.
A lot of inflatable globes.
We roll these things up now to, so they're not just every individual record. Now we're going to just
got it. Okay.
And this where. So where some of the different aspects of, like here we're going to do the one-hot encoding of stock code, customer ID, and things, because those are currently text, right?
Because the country, so if we scroll back up, we saw like US and Switzerland
Exactly,
and France,
exactly. So
UK.
Out of that, for each one of those, we're going to have a one-hot code table, right, with ones and zeros to say, is it Switzerland, is it Spain, is it France?
Yes and no, yes and no, okay.
Is it this customer ID, is it this, description, right? So we got to go through all of that. Creating another one, we're kind of doing some vectorization here with the how close they are to relate to each other, and then their descriptions and things like that. Again, it's coming up with another matrix. And when it's all said and done, then we do this H stack, which basically stacks all our matrices to one final matrix. Okay, and then that's what we're going to use for our training data. So there's X will go there, and then Y is all of those quantity values, those that we rolled up, because again, that's the thing we're trying to predict, right?
Yeah. So and then it returns both.
Yep, exactly.
Perfect.
So now we have just a little bit here, just kind of look at that, see kind of what some of that data looks like there.
The descriptions, and then we see the quantity.
Yep.
3,850.
Yep. So kind of again, go down here, looking to see how sparse the data is. So in very highly sparse data, we've got, makes sense. We've got all of the, not everybody's in that country, not everybody's brought that product, et cetera, et cetera.
Yeah.
So the data becomes very sparse, and so we have very high sparsity.
Yes.
We do. And so now we need to do this pretty standard here. We're going to split our data up for training.
So a certain percentage for training data, and a certain percentage for testing data to make sure that our training model is accurate.
That's right.
Got it.
And then we're gonna basically, in this case, save these off to our file system. So if I were to go out to the file system, I'd see that I'm gonna drop this data on the file system for later use. So here's the, I already set this prefix here. So this is for all of our, where we're going to end with our training data, because when we convert it to protobuf, remember, this is model likes protobuf, so that we're going to.
So you have it converted into train.protobuf, and I see Doug Kelly actually pasted a link in the chat that says, if you want to learn more about protobufs, take a look at this record IO protos, and I will copy that over to another one of our chats as well.
Very good. Thanks, Doug.
Thank you, Doug.
Yeah, so in, there are different, every language has different ways of converting over, so to protobuf format here. So we'll just go ahead and let that run. So that's created our protobuf output. Now we're ready to train.
Okay.
There's a lot to get to train.
Are you going to train today?
Let's do this. I'm going to do this. I'm going to say run. I'm going to run, just say run all. We're just going to let this run here. I've already run this. So we'll just let it go ahead running right now.
Cooking show?
Yeah,
I
do have a pie, a pre-baked pie, absolutely.
We could even actually use some pie data.
Oh,
based on everyone's favorite pie.
That would be
type your favorite pie in the chat.
I love that idea.
Peach cobbler, apple, blackberry, blueberry. What else is it? Pumpkin, chocolate. That's more like a mousse.
Rhubarb.
Rhubarb. Okay, let's get back to this.
Okay, all right. So you can see now all of these things are lit up because that's the curtain thing that's running. So right now this is going through and grabbing all this data. Can I set me up here? So remember that when we train, we use these estimators to represent our job and everything else. So we're bringing in the container. This is one of our pre-built algorithms. So we're bringing the factorization machine in here. All right, and
Doug Kelly said Costco pumpkin pie for him.
Oh, nice, nice. Costco pumpkin. That's pretty specific.
Very specific.
Wow. Yeah, that's interesting. My mom's homemade pumpkin pie and Costco.
Okay, all right.
So we got the estimator here. So here's the job. Here's the thing. And remember, the whole idea, I'm running on a 2 virtual CPU machine with 4 gig memory. That's what my notebook is currently running as, right? But here, I'm going to be able to pull up the big guns and pull in a C5 to do this training.
Why a C5?
Because it really works great with this particular factorization machine.
And then the extra large because we need more RAM and memory.
Right, exactly. We could probably go look at the specs for the C5. And then the other thing, remember we said here's one of the key things.
The regressor. Okay.
Because factorization can do both classification and regression. And this time we're trying to come up with a quantity. So kind of makes sense,
and then you're defining the minimum batch size and the number of factors and epochs. Okay.
Right, and so and these things are things we could save to look at later to say what settings did we use. To go back and say, well, how did we get this magical result? Well, we use this data, this settings, and this size.
So we can actually come back to this and maybe try to replicate the same results.
100%. Right, exactly.
Perfect.
Yep. I just printed off some of these things here because these are key to what we're doing. We need to have a role so that we're allowed to do this stuff.
Okay.
Right? The container is that we're pulling our factorization machine, our container that has our pre-built algorithm out there. And then
the job name.
Just the job name. So we know that that's what we're going to go look at when we go check it out.
So it spits back out the ARN for the role and then the endpoint for the container.
That's right.
Okay.
Well, right. Well, the container or repository that we have our container in.
Yes.
Yeah. Exactly.
Where that image is. Or,
very good. Okay. Right. Yep. Exactly. So here we're going to go through. I've trained it with that name before, so I recognize that, and it's going to run the fit function. So this is where the actual hardcore. This is where it's learning all of those data. Remember all those auxiliary values and setting all that kind of. That's all going here. We're trying to fill in those blanks and in those different.
We're training the fitness.
We're training this thing for fitness.
Okay.
Yeah.
Okay. Hey.
All right.
Machine learning. Get out there and get fit.
That's right. That's right. All right. So then, once we've got that thing trained and running, right, then we can come back. We can hit it with some predictions.
Let's do it.
All right. So we're getting the early returns here from our back in from our training exercise here. You can see some things going on.
We just scrolled by a whole ton of stuff.
That's a whole ton of stuff. And there's different things.
I barely caught that.
Well, and we're only on Epoch 1, so we've got a ways to go because I think we had 25 in there.
We did have 25.
So we'll come back to that.
Yeah. Okay.
And then
don't worry about that. We'll come back to it.
Yeah. So if you go back to the factorization machine and the inference, back to the documentation on this, remember we had the inference formats. So it says what it is, the data type. What does it take in? So this wants JSON.
Okay.
So we're going to set up some deserializers that will take in JSON. All right. So that's what we're doing here. And once that we set those deserializers up and everything else, then we'll be able to deploy that. So this will create a Sagemaker endpoint. And then from that, we'll be able to just kind of take some of the test data in and run some things against it to say, give us some recommendations based on what we just
maybe the top 5, for example.
We'll do the top 5.
Okay.
Yeah, absolutely. So while that's running, this is one way to do this, right? I'm just kind of checking the timing here. Okay, we're good. So one of the other ways to do this, right? Is we're doing this all in one notebook, but what if we wanted to kind of do it more in a way that a repeatable thing where I didn't have to come here and sit here, walk and go through each of these different steps?
We can do that?
We can do that.
Okay.
And we can do that with something called...
But what if I like hard work?
Well, that's up to you. Then go for it. But so another way of doing this exact same example here is to use Sagemaker Pipelines.
Okay.
So I have run this pipeline before here. Go here and look at pipelines.
Now it's pulling up all your different projects and data wrangling. You have the different options, but you're looking at your pipelines here, and you can see when they were last modified and 3 hours ago.
Yeah.
That's pretty recent.
Absolutely. So I ran this a day ago, ran it 4 hours. And then so each of those times I changed something.
Okay.
Right. So luckily it succeeded. And if we go through the executions, we can actually see this execution graph. We can zero in on that thing here.
Nice graph.
It is, isn't it?
So
this is all the stuff.
The data. Okay.
Yeah, which we did manually before.
Yes.
We did a training step.
Fitness.
Okay. Where we did the fitness piece. Now we're going to create a model definition.
Okay.
We'll go back to the other one in here in a second. So that's basically all of the metadata about the model. Where is it? Where is that? What training job was used to training, and things like that.
And then registering the model, is that the ECR that we're talking about?
No. So registering is then taking all of that data that we know about the model and saying store that away so we can check it later to see how did we get here. So lineage tracking of that model. So that's we're going to take a bunch of the data and different metrics that we use along the way, and then register that so we can come back and then see how.
So training step can split into 2 different steps, almost like a parallel, and one is for registering, one is for creating the model, which then we eventually deploy.
Exactly.
Okay.
Exactly.
Got it.
Yep. So
now I'm caught up. Thank you.
Cool. Yeah. And so we're going to go back and look at some of the output of that. One of the things is that model registry.
Okay.
Okay. So this was the model registry that came out of those runs that I did earlier.
Okay.
Right?
One's approved.
One was approved, right? So I can maybe come back in here and take a look at that, and then look at the the settings of where was what execution of my pipeline, where is my model stored, what was so here I use the factorization machine model, so we know all of that stuff. If I had included model quality, which is one of the features we could do, then we could have a model quality report here.
Got it. Okay.
We could have bias reporting. Inference recommender is pretty cool. You can go through it and say, well, create a load test for it, and then let inference recommender come up. But the whole idea is that I can go and then each of those. So if I go back to my here. Let's go ahead and look at 3. So this is where someone.
Why is it pending?
Because we haven't approved it.
Oh, okay.
So this is where we would come back, and we would want to look at things like in the model quality report and things like this. This is a demo. But there might be other things in here that we'd look at to determine some different metrics that we would have pushed forward. So we could say, what was the MSE and all that kind of stuff, right?
So you run the model, you take a look at the data, and then you say approve, or could you reject it?
Yeah, absolutely. Okay. If I don't do anything here, so because I would look at this, say, well, my current model is giving me MSE of 46 or whatever, and now it's 47, and or 44, and that's better. So I'm going to go ahead and improve this. So
approve
you look
the better, reject the not.
Right, exactly. So you can come up here, and then I could just update the status,
train it again for better
approve
fitness.
it, and say this was great.
Then you got to say ship it with AWS.
Team, let's
machine learning.
Ship it.
Ship it with AWS.
All right. Update the status, and now in this case here, I don't have a that wouldn't necessarily kick off a deploy step, but you could.
Okay.
And then you can have further processing that goes on after that in your pipeline. So there's an entire language that we use for coming up with those pipelines. So let's go back. You can probably see some of the Hugging Face that we did from last week.
That was
still out there, yeah. So let me go and change this view. Where's my view? There it is.
So we can go through, we can approve. After reviewing, we can reject. The message may not be as positive as your approval message. Great work, team.
Right.
It may be great work, team, for an opportunity to do better.
Yeah. Let's try again. Yeah. So let's go back to our baking show here. So here we have our deployed model. So here's the process where we create an endpoint. So right now there is an endpoint running on an ML-M4 extra large. Okay. In this case, it's a single model, but we could have done multi-models. So we could have trained 2 different models and then deployed them to the same endpoint.
Is there a reason why you picked the M4, more of a general instance type instead?
I probably what I would do in real life is that I would go back to the inference recommender and determine is that really what I need. So it's good. It's a good starting point, But do I need that much? I don't really know. I would probably want to run through, and then you can look at CloudWatch and a bunch of other things to determine whether or not it is.
Are you spiking in CPU or spiking in memory? Yeah.
Right. So then we just we can read in some data, and just a little quick loop here. Now remember, the data has to look the same as what we presented to the model before. So we're going to go through some of the same stuff here to prepare the data that we went through before. Remember that one encoding routine that we went through, the vectorization routine. So we're going to do some of the same stuff.
This is all for our testing data.
This is all over our testing data. So it looks similar, right?
And massage it the same way.
Yep.
Got it.
And then say, okay, so give me back the top 5 recommendations. I didn't delete the endpoint.
So now they have cake stands and kitchen scales instead of inflatable globes.
Exactly. Who knew, right? So this is still running, so we can go ahead and see how fast it would give us back, on 100 recommendations.
100?
I know, I'm crazy that way.
You're going to run it again? You sure? Okay, let's see
how long it takes.
Let's see how long it takes. I'm counting.
Yeah.
I'm counting.
That was probably a risky thing to do on a live demo, right?
But
we'll see.
Live on the edge.
That's right. Okay, well, that's baking. Oh, there we go.
There we go. 100.
That wasn't too bad.
It only took, I lost count.
And one of the things, again, you could have different things like the rankings that we talked about and stuff like that to kind of look at. So, it's even different products here that we look at. And then this is what I was talking about before. We want to put that stuff in the model registry, right? So this is where we're going to take all the data. So there's multiple different things, objects and artifacts that you can store in the registry that tells you about the jobs that you ran, the things about the model, where it's stored, and stuff like that, right? So this is just some of the things that we're going to store. So we're creating these different artifacts.
And where is all this stored at?
It goes into the model registry.
Okay.
Okay. So you saw that model registry that I went to a second ago,
Yes.
right? So it's basically I'm populating that
You
registry.
can pull that again. Okay.
Each job. So I have one registry, and then I get multiple different iterations of my executions, et cetera. So I can go and see what happened each time I ran those.
Perfect.
So this is a little bit about the model, right? Where's the model sitting? Where is it in the S3? How can I hit its URI so I can pull it back in? Because my application, when it really happens, I'm gonna have to pull that thing in, deserialize it, and make it available, open it up, and be able to, so I have to do all that stuff. So it's just good to know where it's at, right?
You get the URI of where it's at, and then it says using existing artifacts. So you already had one.
Yep.
Okay.
Yeah, and then, so in this case here, I took the earlier training job and just added on some metrics there. And when it's all said and done, here's the model definition. I've already got one with this model name in it, so I probably should have changed this to live here. And then finally, store everything in that package group. So it's that lit ship it.
Let's ship it. Retail recommendation.
Yes, exactly.
Let's.
So,
I just saw that.
Yeah, I think it was out here too. So
it's okay.
But anyway, so you get the idea. So the whole idea, why am I doing? Here's the different metrics about the jobs, the statistics. It could be, in this case, we ran a script to come up with these metrics. So just like we did the pre-processing stuff, there's an evaluation script that we ran and dig into that. And that came up and gave us the metrics that we were trying to use, like the MSE and things like that. We were trying to minimize and dump all that stuff out. Okay? Alrighty.
What else do we have going on?
And then once it's in, what's nice is that once it's in there, then you can do the run the lineage tracker to get information about that, right?
Perfect.
So then you can get reporting on all of your efforts. So
I can see all the tar files, protobuf files, factorization machines, so the image and so forth. This is really cool.
Yeah, it's pretty cool because you really care about what data that I use to train this thing, right?
Yeah.
So and you wouldn't want to go through the retraining cycle, everything again.
It takes a long time.
So go ahead and use the data that you already have ready to go.
Why do the same thing over and over again?
I don't know.
Unless you have to retrain.
Don't do that.
Unless you need to retrain your data.
Yeah.
Your model.
So are there any questions about this process online there?
No. It looks pretty good. I don't see any questions in the chat. Our chat moderators are doing a really good job of keeping up and answering everyone's questions, so great job.
Very cool, very cool.
I think we have another poll, though.
I think we do.
Ah, here we are.
Yeah.
So let's see. Type your answers in the chat, 1, 2, 3, or 4. Which of the following SageMaker features would you feature? 1, would you use to automate the machine learning workflow? Fred showed us a couple options. He showed us where the models are, and he showed us I won't give it away. I will not give it away. SageMaker Feature Store, SageMaker Hosted Endpoint, SageMaker Model Registry, or SageMaker Pipelines. Type 1, 2, 3, or 4 in the chat. And let's go ahead and let's see. I'll pull it up. I see 4s so far. Nothing but 4s. I think everyone is telling us it's 4. And let's see.
I like that answer. Let's see. All right, SageMaker Pipelines 4s. It is.
All right.
Yeah, and they're a very powerful MLOps tool. You know, so it's a good one to start to embrace as I go through. I'll admit I'm a notebook person, and I'm getting more and more into pipelines, and it's a lot of fun, very effective.
That was really cool. Fred, thank you for walking us through that and walking us through the demo.
Yeah.
For everyone who's watching, we do have some homework for you, so let's go ahead and pull that up.
Sure.
Go ahead and talk about personalization. So what do you need personalization for? What kind of problems are you trying to solve? Go ahead and post on LinkedIn and use the hashtag Let's Ship It and tag myself, Aaron S. Hunter and Fred Gratian. And we will go ahead and jump over to our Q&A section. So
for
those who have been hanging out type your questions in the chat. We will do our best to answer them. We also have chat moderators here to help. Liam's over here just kind of hanging out. Hey, Liam, thanks again for being here. So let's see. Doug Kelly has a question for actually everyone.
Okay.
Has anyone tried Sagemaker Pipelines? What were you building? Here is the developer guide to read more. So thank you, Doug. All right, perfect. So let's do this. I pasted the send a message as part of my message that I sent. All right, so we have a few minutes left here. Let's go ahead and see if there are any questions while we wait for the chat to pop back up. But Fred, what was your favorite part about everything that you just showed us?
You know what? My favorite part really was to dig into pipelines. I've run a bunch of them, but I haven't had to construct a lot of them myself.
Okay.
You know, so going through and building this lineage piece, I had never done that. So kind of, you know, in adjusting it and adding a few additional pieces into the pipeline was really kind of cool. So if you know, basically with a pipeline kind of works too, to simplify, I'm just going to go all the way to the end of this pipeline when I actually go to submit it. So these are the steps, right, that I created. So you're just going to go through each of those steps, and then you just go and add a little bit on, and then execute it, and and build on to these things.
Create the data set, train it, create the model, register, deploy.
Right,
okay.
right.
Okay,
and if I just want to change, if I need to tweak one piece of that, then I still have the whole pipeline, defined and everything else. So it's very interesting to use. I've used different tools in the past, and it's really cool. All
right, I don't see any questions so far. Maybe you answered everyone's questions already.
All right.
You're that good.
I don't want that.
All right, we'll give it a few more minutes here, but until then, I guess, let's go ahead and bring the slides back up.
Okay.
So episode 4 homework. We don't have questions. Typically, we have more questions than this, but this has been a great episode. Really good demo, really good walkthrough of using personalization and pipelines and model registry. Actually, one just popped in. So can you talk a little bit more about model deployment? So Muo is asking, I see how you built, train, and deploy the model, but how exactly is my startup going to use it in real life? Do I plug a link in the website somewhere?
Oh, it's a good question. So let's do this. Let me make sure if I can. My glasses on to do some of this here. So what all got created when we did all that stuff just now, right? So if I go into SageMaker, cool. So I think we talked about this in one of the episodes here, but what we created was an inference, right? So we created some endpoints.
Let's zoom that up a little bit.
Sure, yeah.
If you're able to.
Yeah, good idea, because I can't see it from here. So.
No, yeah, it's tough for everyone else too.
Yeah. So these are the models that the endpoints we just created.
Okay.
Right. So this is live here.
June 23rd. Okay.
Yeah. So nothing up my sleeves. I have no sleeves on. But here's the URL.
But we're in Vegas, so there's magic everywhere.
There is magic everywhere. Yeah. Are you Penn or Teller? I can't really tell. So here's this URL. So this is what you would hit with front endpoint. So in our case, we had an object, that estimator object, right? And then we did the estimator. We did the .deploy. If I was going to use this in my application, though, I would be hitting this endpoint. So I would take it, and as long as I have an access key and a secret, just like any of our other APIs and things like that, I could then hit this endpoint with the invocations. So I would set up a deserializer because everything has to be in JSON, right?
Got it.
So all that kind of stuff. I would run some of those things that prep the data.
Yes.
And then once I had all that data prepped, just like we did, we could hit this URL directly. All right. So that's kind of what we did when we did the deployment.
Okay.
And remember, we chose the ML M4X large. So you look here, we have just that. Well, we're saying all traffic to that one instance.
Okay.
So if I had another model out there, if I had done multi-models to this endpoint, then we'd see the other one, and we could add the weight, and we could say what percentage we want to go, and all the other fun stuff.
Perfect.
So yes, so this is what we just accomplished. We have an endpoint running here. This is a live endpoint, and if you, as long as you had access keys and secrets to get to this, you could hit that endpoint. Did that help with the answer?
It does. It does. I think one is, do you have an example, or can you think of any examples how maybe a startup can use it?
Yeah, I mean, if once you train this model, then you work it into your applications. So this could be, I could hit this with a mobile application. I could hit this with an API gateway. I could hit this from JavaScript. I mean, I can hit this endpoint from anything. So you would be sending in this case, this model, right? What we're trying to do is predict the quantity of an order, or which orders. So, and give that recommendation. So basically, remember how I just said 100 recommendations?
Yeah.
That's exactly what you would do.
Change it from 5 to 100.
Just call it with those parameters, and say, give me back predictions. Give me
cool.
for this user, tell me which of those products. So this is a trained model that would give you back those predictions.
That's awesome.
Those recommendations.
That's awesome. Yeah. The viewer says thank you.
Oh, you're welcome.
You're welcome.
Yeah, and again, remember we did talk about personalize.
Yeah.
So that's another one where it's like you still go through the process of training the models with the data. You're just not using Sagemaker. You're still feeding it your data and things like that, and then you end up with a personalized endpoint there to work with, right?
Perfect.
So.
Cool. Well, I don't see any other questions here, so let's go ahead and bring the homework slide up one more time and remind everyone we do have homework.
That's right. Do your homework.
Sorry, not sorry. Do your homework.
Do your homework.
Don't let your dog eat it, your fish, your cat, whatever you have. But go ahead and post it on LinkedIn. What do you need personalization for? Share your use cases and problems you're trying to solve. Post that response on LinkedIn using hashtag Let's Ship It. Tag myself, Aaron S. Hunter, and F. Gration.
Yep.
It's not Fred Gration.
It's not.
That might be someone different.
I don't know why.
But F. Gration.
Could be my uncle.
It could be your
Same name.
And then we do have some bonus content for you, so go ahead and watch how to deliver personalized recommendations using Amazon SageMaker on YouTube. We have a playlist and a video there. But that's pretty much it, Fred. Is there anything else that you want to bring up and talk about?
Nothing other than to say tune in next week, and we'll have a lot of fun.
Tune in next week for episode 5, Thursday, June 30th at 4 p.m. Pacific. And from all of us here at AWS, thanks for tuning in. And yeah, hope you enjoyed Remars with AWS On Air. All right, everyone. Take care.